All right, we're back. We're still on page 3, notes 9, Calc C. We're finding intervals of convergence. It takes a little practice, but once you get it, I think you'll be fine. So let's do it. So ratio test. Can we go a little faster on this one? I don't know. I just want to go fast, but then I'm like, no, slow down. But like, if you want it slower, slow the video down. Like, that's on you. Make the choice. N squared, x plus 1 to the n. All right, what cancels? Still gonna be some n's, I feel like. All right, so n plus 1 squared still gonna be there. Absolute value of x plus 1. The n factorial and the n plus 1 cancel to give me just n plus 1. And I get an n squared. So what do I got? I have a third degree polynomial over a second, second over third. Second over third, that's going to be 0. So this is 0. So that's surprising. Is that surprising? I guess that's not that surprising. It's like, feels a little like e to the x, but like with that n squared in there. And I've never, I don't know where to look to like learn more about that, because I would love to learn more about that. I'm sure there's something going on. But anyway, 0 less than 1 for all x. So the radius is going to be infinity, and then the interval, I'm just going to say x is an element of the reals, because any real number will work. That thing converges no matter what you plug in. I guess the n squared is like very small compared to n factorial. I don't know if I would have guessed that. Probably not. This one almost feels like cosine, but not exactly. All right, so first thing I'm gonna do is rewrite it 2 to the n, x to the n. Like, it doesn't alternate, it doesn't feel anything like cosine. That 2n factorial though is what made me think that. All right, limit as n approaches infinity of absolute value 2 to the n plus 1, x to the n plus 1. So this would be 2n plus 2 factorial, kind of gross. And then we'll have 2n factorial. I feel like you can tell right now this I think this is going to be all reals. It just feels 2n factorial grows so fast. Like, how is it not going to be all reals? But let's continue. But like, why are there so many examples of all reals? Who wrote these, and why did they do such a bad job? Maybe I'll like find more. I don't know. No, I don't have any time in my life to make more videos, so I don't know about that. And then we'll have 2n plus 2, 2n plus 1. Delightful. All right, so x is a constant, so a constant divided by like a quadratic, definitely 0, which is less than 1 for all x. The radius, oh god, what? The radius is infinity, and the interval is going to be x is an element of the reals, which like kind of feels right. 2n factorial grows really fast. Man, if I had known all of those were just going to be that, first of all, that's annoying. Well, whatever. It's fine, I guess. It's still examples, what have you. All right, so a little summary here at the bottom for you. Interval of convergence, use the ratio test. That gives you absolutely convergent. So it converges absolutely everywhere the ratio test indicates that it should. Then we test the endpoints. They're almost always alternating geometric or p-series, like almost always. And then we write down our interval. So this process is not that bad. And we will be back in the next video to do some other stuff. So I will see you there.